This is a video on how to use a constant current voltage regulator for making GANs. Okay, I'm getting ready to do a run of GANs. This is a new power regulator in order to be able to control this GANs at a constant current instead of a voltage. So I'm going to start up the GANs job, and then I'm going to turn on the air supply because it makes a lot of noise. So I'm going to start this part first. Okay, so first thing I'm going to do is plug it in. There's a power jack for that. Okay, so now there's a red light on. It's saying it's already in constant current. Well, that's really good. Probably because I had it set up that way yesterday. So what it is it's showing 0.248 amps. I want it to go a quarter of an amp, 0.25. So I'm just going to turn this up. There it goes. Let's see, I'll try it again a little bit more. Try to get it in there. Okay, 0.25 of an amp. That's a quarter of an amp. Okay, so I found this job runs better at a quarter of an amp. Okay, so the very lowest amount of voltage here it's down there at 0.6264. So what I'm also going to do is I'm going to turn the voltage knob up quite a ways to give it lots of headroom. So as this job goes further on during the day, it'll be able to stay in constant current, because as this job progresses, the load changes and it requires more voltage. So right around at the end of the job, it's going to be running, say, 1.2 volts, something thereabouts. And in order to get it to run at a quarter of an amp at that voltage, I have to supply that voltage here early on, so that way it's ready. Even though you don't see it happening on the display, by turning this voltage knob up all the way, I'm going to make sure that there's enough voltage at the end of the job. Because right here at the beginning of the job, it uses the smallest amount of voltage, which is right around 0.6 of a volt. Okay. So I want to mention that you can also do this same setup with the standard lab power supplies that show voltage and current, and it's a pretty standard feature in those lab power supplies that they have constant current as well. I'm only doing this because this is a cheap module. It only cost I believe it was $16.50 or somewhere thereabouts. I got it at Amazon.com. Okay, so now what I'm going to do now is I'm going to turn on the air supply. It's going to make some noise. So okay, I'm going to also take this camera off the tripod here to get a little better view of what's going on here. Alright, so here's the GANs job. Oops, move the knob a little bit. Okay, there it is. Alright, so there's the air supply running there, and there's a nano-coated copper plate, and then there is a brass plate. Now, this type of GANs was described in I believe it was the 86th Knowledge Seekers Workshop, which was right after the Blueprint Teaching Week on making a maggraph. So I do believe that this is the GANs that is used in the manufacturing of the maggraph. And so when it's finished, I got some right here. Okay. Here's some in a container right here when it's finished. And if we look down here, it has sort of an olive green color. And I believe that is the finished GANs. And so this GANs runs pretty fast. Like by the end of the day, and probably after about an 8-hour shift, this job will be done, and I'm going to shut the job down. But what I really like is, I really like the fact that I can set up the job for constant current. Now, In the Kesh material, it was Mr. Kesh, I believe, who recommended that to run this Gans at 1.5 volts and about a half an amp. Okay, so I made some with those settings, and I think I'm gonna like it a little better if I run it at 1/4 of an amp. It's just, I think I'm gonna get a little better result, because that other Gans came out a little dark for me, so I think I had too much current. So anyway, I'm hoping that this is going to do a little better at 1/4 of an amp. So anyway, the main thing about this video is this control module here. This is a power supply regulator, which is very inexpensive and very reliable. And I forgot to mention that it's running from this AC adapter here. Now that is a 12 volt, 1.8 amp AC adapter. So it's got plenty of capacity for plenty of current, so I like it. So I do most of my work with this particular AC adapter when I'm using these types of voltage regulators. So, because there's no problem with, you know, being able to handle enough current. Okay, so I can talk a little bit more about this. Okay, so I'm going to come in a little closer here. All right, so the input voltage on this can be anywhere between 5 volts and 30 volts, and the output voltage that it creates is anywhere from a 1/2 volt to 30 volts. And as you can see right here, it's able to make the 1/4 amp of current with almost 0.6 of a volt. It's a little over 1/2 volt. So it's at the very low end of the output on this. So it's suitable for this job, because it falls right into the range of what this module is capable of. So that's about all I'm going to show for this video. I really like this inexpensive module. I can set it up very fast, and it's I still use the lab bench supply, but I like this little module. So I'm going to provide a link for where I got it at Amazon. I'll provide a link for that in the description. I hope you liked the video. Thank you for watching.